growmode system was developed for the cultivation of plants for research on a mass scale. The system has been operating for several years in research centers in Israel, and the company is now beginning to market it internationally. The system offers numerous advantages for research growing. It is possible to grow a variety of plants, from small plants such as Arabidopsis to large ones such as corn. The intervals between shelves can be adjusted according to research requirements. In each system, from 2 to 10 square meters of plants can be grown, depending on the number of growing platforms ordered. System assembly is very simple, and its installation takes about a half an hour. The basic structure is a central column with 2 large growing trolleys that are fed by the column. The trolleys have wheels for easy maintenance. All the control, electrical, water, and drainage pipes are connected using quick connectors. The system is operated by a digital controller with numerous control features that afford the researcher maximal research flexibility, local activation, and control of illumination intensity, airflow, irrigation, and drainage. In addition, the controller can activate the long-term growing systems at different intervals, according to daily and weekly cycles. The airflow system operates by suctioning air from the plant vicinity using silent and isolating bellows through grids in the column and ejects air through vents in the roof. The system has 2 powerful bellows that supply air velocities of 0.3 to 1 meter per second on the plant surface. The controller enables control of air intensity at 50% or 100%, and air calibration is performed using the grids in the column. A unique irrigation system is installed in grow mode, enabling control of each shelf separately, with or without the addition of fertilizer. When the controller is pressed, the irrigation valves are opened after irrigation type is selected. Water is fed through a central valve and secondary valve that directs it to the shelf requiring irrigation. Water flows through the internal and external pipes to a filter. During draining, the filter accumulates the sand and dirt, and every subsequent water flow cleans the filter. The shelf is filled by a perforated stainless steel net on which the plants are placed. Water enters through a diverting plate that prevents water spurting under pressure out of the shelf. A stainless steel level controller sets the water level in the growing platform, can be adjusted. For plants that are immersed in water, the researcher sets the immersion time, and then water is drained out automatically via the filter and pumps into the accumulation tank. The water is channeled through the main pump and pressure drained via the pipes to the roof. In grow mode, a separate illumination system is installed for each growing platform. The system can be mounted at varying heights above the research plant. The lamps selected are fluora type, and they provide light that is closest to the sun's spectrum. Optional UV lamps are available to simulate a broad spectrum of light. The illumination systems are controlled by manual activation of the controller or based on a daily, weekly cycle that is also entered into the controller. In case of a fault, it is possible to bypass the system and operate it manually, using an external switch that bypasses the controller and activates a mechanical clock for a daily cycle. Since the system operates based on an intense regime that uses substantial amounts of water, there is a danger of flooding if a fault occurs. Consequently, the system is connected to a flood prevention system assembled outside the column on one side. If water accumulates on the floor, the system sends a flood warning to the controller. The controller immediately closes the 2 main valves and displays a fault message on the screen. To enable the researcher to control the temperature and humidity in the growing environment, precise temperature and humidity readings in the plant's vicinity are displayed on the controller's screen. Air is discharged via pressure from the bellows through the roof. In addition, connection of the water flow entry points, with or without fertilizer, and connection of the draining system, sewage, is via the column. The system is connected to the power supply via a quick cable for one-phase electrical power. There is also a connection for external communication with a technician's computer or inter-column communication system. The column has a back service door for easy maintenance that enables access to all the internal systems from the back. The system was developed for mass cultivation of plants for research. The irrigation system is unique and enables plants to absorb water from their roots. This irrigation method eliminates almost all harmful insects that develop due to moisture on the external surface of the soil. The system provides numerous advantages over existing growth cell systems. Growing and protecting research plants, particularly Arabidopsis, under the healthiest configuration for the plants. Growing plants in unique sanitary conditions that prevent and repel insects. The system is designed with maximal flexibility that provides researchers with a wide variety of growing and research options. Very high cost-benefit ratio of 1:12 compared to other growing cabinets. Growing plants for research on large scales. Simple and user-friendly operation. A unique irrigation system based on water absorption and immersion of the plants for fixed eternals. Grow Mode, the most advanced and flexible system for plant growing research.